Hi, good to see you again. Welcome to Block 5, Addition and Subtraction of Fractions, Lesson 6. I'll share my screen. So, in your previous lesson, you learned how to add and subtract fractions from integers. So, it was a very important lesson where you learned how to add and subtract fractions from integers. Integers mean whole numbers. In today's lesson, you're going to understand and use equivalent fractions. Another very important lesson in helping you build a very solid foundation of understanding how fractions actually work. But I would like you to click on the like button for the videos, subscribe to the channel, click on the notification bell so that when new videos are released, you will be notified. Also share the video to those you think can benefit. By doing that, you help us grow our mission to provide a platform where children all over the world, regardless of their economic situation, can have full access to secondary maths education, provided they have internet access. So your charitable work could be to provide internet access to a child who can have good maths education that can have a tremendous impact in their life for a very long time. Thank you. Before we start, I would like you to answer the retrieval practice questions in 3 minutes. 2 minutes should be enough, but take your time, work at your own pace. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. Here you were asked to circle the non-unit fractions. Now, unit fractions, you know from our previous lesson, are fractions that have 1 in the numerator. There are only 2 fractions that satisfy that condition, so the non-unit fractions are shown there. Now, you can see that we have 2 bars shaded in the bar model. So here, this represents 2/5, and for the next one, that represents 4/10. Let's do some new learning. So, have a think. If you were asked to represent or to draw another bar model that has the same width as the bar you see there, you know that that bar is 1/4. But if we split the one underneath into 8 equal parts, what would you say is the fraction for this part? Well, you would say it is 2/8. But note that they are of equal width. So would we say that 2/8 is equivalent to 1/4? Of course, yes. Let's do another one. This time, if we have the same bar that has the same width, but we split it into 16 equal parts, and we happen to shade the same width as the width that is shaded above, we can see that we have shaded 5 parts. Would we say that 5/20 is 20 parts? Would we say that 5/20 is equivalent to 1/4 and 2/8? Yes, we can say that. And what about this one? If we shade these parts, we would have 3 parts shaded out of the 12 parts. Of course, we would say that 3/12 is also equivalent to the other fractions we see above. What if they are written as numbers? How can we fill these in? Well, I'm sure you remember the numbers that we worked with earlier. So here will be 2/8, that will be 3/12, that will be 5/20. And of course, we can have so many other numbers there. It can be 4/16, it can be 10/40, so on and so forth. But what do you notice about the relationships between the numerators and the denominators of the fractions, or the relationship between the numerator and the denominator of each of these fractions? Well, something you would notice is that each of these fractions, when you multiply the numerator by 4, you create the denominator. So there is a multiplicative relationship that you find, and that is the same across each of these fractions. Or if you divide the denominator by 4, you would get the numerator. What about the relationships between the numerators and the denominators amongst the fractions? Comparing a quarter and 2/8, we would see that if you multiply the numerator by 2, you have to multiply the denominator by that same amount to get the denominator. Let's look at another one. You can see that a quarter, if you multiply 1 by 3 and you multiply the denominator 4 by 3, you'll get 3/12. It's the same for 5/20. And the other one for 10/40. So you can begin to see that we can have multiplicative relationship if you spot them really quickly and they are integers between the numerator and the denominator of the individual fractions, and they stay the same if the fractions are equivalent to each other. Or to scale the fraction to see an equivalent fraction, you would have the same integer or the same amount being multiplied by the numerator and also by the denominator. Here is something to think about. Here, this young man says, called Mo, that 2/3 is equivalent to 6/12, or is equal to 6/12. Sorry, equivalent is the 3 lines. So 2/3 is equal to 6/12 because 6 is a multiple of 2 and 12 is a multiple of 3. How do we prove him wrong? Have a think. Well, you can see from what we've learned that although we can multiply 2 by 3, but we cannot get 12 by multiplying 3 by 3. So they are not equivalent, or they are not equal to each other. It's now time to practice what you've learned. So pause the video and answer question 1 in 3 minutes. Assuming you've paused the video and you've answered question 1, we're using the fraction wall to answer these questions. Here, you can see that these are all equivalent fractions. Note here that we multiply the numerator and denominator by 5. Here, we multiply by 3 to create the equivalent fraction. Here, we're dividing by 2. Here, you're multiplying by 2. Here, you're multiplying by 2 each time. Here for question F, you were asked to write 3 fractions equivalent to a half. By now, you should recognize that you have different answers because you just think of a number that you can multiply the numerator by. You then use that same number to multiply the denominator, and you create an equivalent fraction. Question 2, pause the video and answer question 2 in 3 minutes. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. You were asked to write the equal sign or the equal that is crossed out to show they are not equal, to show whether the fractions are equivalent. And here you see the answers really quickly. Pause the video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So here you were asked to complete the bar models to show equivalent fractions. Now, this is straightforward because we just need to shade the parts that share the same width with the part that is shaded. So this is 3/5. So we means when you share the same width, we've shaded 6 parts out of 10. Here, you need to split them into equal parts because it's not been done. So here we'll have 3/9. Here you have to show that they have, so 4/5 will mean shading 4 parts. 12/15 will mean shading equal number of parts, but here you have to split these into 15 parts if you wish to do so. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Here you were asked, what equivalent fractions can you see in the diagrams? There are various answers that we can see. So here we have 1, 2, 3, 4, 5 by 1, 2, 1, 2, 3, 4. So that's 20 parts. So this will be how many parts are shaded? So 2 by 4, so 8 out of 20. And then you have different answers that are equivalent to 8/20. You apply the same here. Okay, let's move on to the second part of our lesson. So we'll look at our first example. How do we fill the numbers that are missing? Well, remember that we can have multiplicative relationships between the numerators and the denominators of other fractions. We cannot see the relationship between 12 and 40 because 40 is not a multiple of 12. But what about looking at the denominator for 15 and 5? We can see that 3 works. So 15 divided by 3 should be 5, which means that using the numerator, 12 divided by 3 should give us the correct answer for the numerator. Now we can see that there exists a relationship between 40 and 4, which is if you divide 40 or multiply 4 by 10, you will get 40. So if you multiply 5 by 10, you should have the denominator for 40, which is 40 over 50 as a fraction. Here, Whitney says she can find all the fractions equivalent to 2/5 by doubling the numerator and doubling the denominator and repeating that process. How can we show that Whitney is wrong? Well, remember, there is not only one integer that we can use to create other equivalent fractions. There are so many integers. If we think about our number system, we have an infinite number of possibilities. So we can use 3, we can use 4, we can use 5. You can keep counting. So even though 2/5 can create other equivalent fractions, but what about if we use 3? What about if we use 4? What about if we use 5? We will create other equivalent fractions that are equivalent to 2/5. So Whitney is wrong. It's now time to practice what you've learned. So pause the video and answer questions 5 and 6 in 2 minutes. Assuming you've paused the video and you've answered questions 5 and 6, here are the answers. Let's discuss them. So all these fractions are equivalent. You are asked to work out the missing numbers. And those are the missing numbers. So you just check the denominators to see the relationship between them, and you use that same multiple to create the numerators. Here you're asked to write 5 fractions that are equivalent to 36 over 48. You can divide, you can multiply by an integer, and you can create so many answers. Pause the video and answer question 7 in 4 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Here you were asked to complete the equivalent fractions. You can see here really quick, I'll discuss them, some of them. So here you see that you're multiplying by 4, so you multiply that by 4. Here you're multiplying by 2, so you multiply that by 2. For C, you can see that you are dividing by 5. Okay. So, 15 divided by 5. Or 3 times 5 will give you 15, so 8 times 5 will give you 40. Here you can see that you are multiplying by 2. Or dividing by 2. So 24 divided by 2 will give you 12. Here, you can see the relationship here is to divide by 5 or to multiply by 5 going that way. So you multiply that by 5, that gives you 15. Here, the multiplying factor is 7. So you multiply that by 7. Here, the multiplying factor is 11. So you multiply 5 by 11. Here, the multiplying factor doesn't exist. You cannot really see it quickly between 12 and 14, but you can see it quickly between 30 and 5. So the multiplying factor is 6, or the dividing factor is 6. So 30 divided by 6 is 5. So 12 divided by 6 is 2. Now that you know this is 2, you can see the relationship between 14, okay, and that one should be 7. So you can then multiply 5 by 7. All right, let's move on. Pause the video and answer question 8 in 2 minutes. Assuming you've paused the video and you've answered question 8, here is the answer. So you were asked, here are 2 fraction cards. What could the missing numbers be? Give 6 possible answers. There are so many answers. We could use this one, 12 over 8. Okay, so dividing by 2, that means that should be 6 and that should be 4. So there are so many possible answers. And that brings us to the end of our lesson. So far you have learned the concept of equivalent fractions, and it's a very important concept that you can use in other aspects of maths. Well done for taking your learning seriously. Until next time, take really good care of yourself and your friends, and bye-bye.